Okay, an example I hope we never find ourselves in. A young woman and her boyfriend plan to elope, but she must rescue him from his mother who has locked him in his room. The young woman has placed a 20-foot long ladder against the house and is knocking on his window when his mother begins to pulling the bottom of the ladder away from the house at a rate of 3 feet per second. All right, so information we know so far, it's a 20-foot long ladder and it's moving away from the building at 3 feet per second. So what we really want to find out is how fast is the top of the ladder and the young couple falling when the bottom of the ladder is, let's go with 12 feet. First of all, I don't think I'm going to do the 16 and 19, but if you can get through the 12 one with me, you can repeat these same steps and get the 16 and 19. All right, so how fast are we falling? Bad situation to be in, but let's give this a shot. So the first thing is draw yourself a picture if that helps out. We kind of have one over on the right-hand side. I can go ahead and say it's a 20-foot long ladder, so that's going to be 20 on that side, the hypotenuse of the triangle. We're going to treat this as though it's a right triangle because we picture, over the span, it's going to be basically a right triangle, upright building, flat land. All right, the other information that we'd like to kind of start filling in here, I'm going to say X is the horizontal distance going across here, and Y is going to be our vertical distance. So we are told that the horizontal distance is changing with respect to time at 3 feet per second. So that's 3 feet per second, and it's increasing because it's being pulled away from the building. All right, the other things we would like to know are we don't know what Y is, but we do know that the ladder is 12 feet from the building. All right, just doing part A here, so I can say X is going to be 12 in our case. Eventually what we would like to know is how fast is this couple falling. We want to know the change in Y with respect to time. All right, that's the big unknown on this one. Now we also don't happen to know what Y is in this case. So we do have a formula, the Pythagorean the Pythagorean theorem. Lots of times we write it with a squared plus b squared equals c squared. But in our case, I'm going to say x squared plus y squared equals 20 squared. Okay, go with me on this, right? It's the base times the height, the base squared plus the height squared equals the hypotenuse squared. The hypotenuse across from the right angle. All right, we're going to use this formula for a couple different things. The first thing is we know 2 of the 3 sides of our triangle. We can go ahead and fill in the 12 for our x. So we have 12 squared plus y squared equals 20 squared. 12 squared is 144 plus y squared equals 400. Let's try to solve for y by isolating the y squared first by subtracting 144 from both sides. That'll leave us with 256 on the right-hand side. We can eliminate the square by applying the square root to both sides. So this will put y equals 16. Now I'm only using a positive in this case, even though we applied the square root to both sides, because this is a real-life situation and that window is above ground. All right, so you may be saying, okay, one more piece, we still need dy dt. So what we're going to do is use this exact same x squared plus y squared equals 20 squared, or 400 on the right-hand side if you'd rather, but we're going to differentiate this with respect to time. All right, so one term at a time here. Let's go through and we're going to differentiate x squared will give us 2x, but then we want to have dx dt. All right, and the reason for that is we just took the derivative of an x with respect to time. Plus the y squared, its derivative is going to be 2y, but next to that I want to put a dy dt because we just differentiated a y with respect to time. Now on the right hand side, it's easy to get a little bit confused here, but 20 squared is the same thing as 400. That's just a number, that's a constant. So what we'd like to do is take the derivative of a constant, that's just going to be 0. All right, thinking about what can we now fill in? Well, for x, we know that our x value in part A anyway is 12. dx dt we identified as it was increasing by 3 feet per second, so 3 gets plugged in there, plus 2 times, instead of y, we solved down and said for this right triangle over on the left hand side, y has to be 16. We still don't know dy dt, but it's going to equal 0 over on the right side. So from my point of view, I see a bunch of numbers and dy dt. So let's work on solving this down and trying to get dy dt on one side by itself. So first of all, we have 2 times 12 times 3. That's going to work out to be 72. Plus 2 times 16 is 32. But we still have that dy dt attached to this, equals 0. Well, it looks pretty easy to solve down. We'll get 32 dy dt equals negative 72. And then to get dy dt by itself, we just divide both sides by 32. That'll isolate dy dt on the left side. And on the right-hand side, it makes sense that it's negative. This is actually going to equal as a decimal negative 2.25 exactly. And our rate here is going to be feet per second, just like the rate was in pulling that out. All right, so if you can follow what we just did in part A with 12 feet from the bottom of the wall for that ladder, you could repeat this with 16 feet in for that x and 19 feet in for the x for part C. So I hope this helps out. That Pythagorean theorem, a squared plus b squared equals c squared, comes up a bunch in these types of problems. So I hope this helps. Good luck.